Hello student, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve a problem from the chapter Real Numbers exercise 1.3 first problem. So see student, what he is asking to find as write the following rational numbers in their decimal form and also state which are terminating and which are non-terminating repeating decimals. So student, here he has given some rational numbers. He is asking to write them in the decimal form. So then after we have to say among the given rational decimal forms, we have to say which are terminating and which are non-terminating repeating decimals. So see here there are 5 bits in the first problem student. This is first one, 3 by 8. So now how can we write the decimal form of the given rational number? Simply by dividing the numerator with the denominator, we can get the decimal form of the given rational number. So this is the previous knowledge you have familiar in the previous class. So here also we have to continue the previous knowledge. By dividing the numerator with the denominator, we have to find the decimal form of the given rational number. Then after we have to say whether it is terminating or non-terminating repeating. If the division is completed, we can decide that the given rational number has a terminating decimal form. Otherwise it is non-terminating repeating. So now to find the decimal form, we have to divide the numerator with the denominator. So see student, 3 by 8 he has given. So by dividing the numerator numerator by the denominator, we get, so what we get, I am writing student, we get, so see here numerator is 3 and the denominator is 8. So it is very clear 3 is less than 8, so it won't go. So write a decimal and a 0 here. So how many times it goes? 8 3s are 24. 8 3s are 24. So 30 minus 24 is 6. Again write 1 0. So how many times it goes again? 8 7s are 56. So 8 7s are 56. So 60 minus 56 is 4. Again we can write 1 more 0. So how many times it goes? So 8 5s are 40. So 8 5s are 40. So the remainder is 0. Now the division is completed. So therefore we can write therefore 3 by 8 is equal to how much? 0.375. This is the decimal form of the given rational number, and it is a terminating decimal. So since the division is completed, we can say that it is a terminating decimal. 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 So simply by dividing the numerator with the denominator, we can decide whether it is terminating or non-terminating repeating. So student, this is the first bit in the first problem. Next we have to solve student, this is the second bit in the first problem. 229 divided by 400. Again we have to write the decimal form of the given rational number. Then after we have to say whether it is a terminating decimal or a non-terminating repeating decimal. So first we have to divide the numerator by the denominator. By dividing the numerator by the denominator, we get here the numerator is 229 and the denominator is 400. So it is very clear student, numerator is less than the denominator, it won't go, so write a decimal and a 0 here. So now how many times it goes? 4 5s are 20. So 400 into 5 is 2000. So now subtract. So 2290 minus 2000, we can get 290. Again we can write 1 0. So now how many times goes? 4 sevens are 28. 4 sevens are 28. We can get 2800. So again subtract, we can get 100. So upon subtraction we can get 100. So again we can write one more 0 here. So how many times it goes? Again 4 2s are 800. So 800. So again subtract, 1000 minus 800 is 200. Again we can write one more 0. So here how many times it goes? Exactly 5 times. So 4 5s are 20, therefore 400 into 5 is 2000. So the remainder is 0. So here also the division is completed. Therefore we can write the decimal form of the given rational number 229 divided by 400 is equal to how much, student? 0.572 0.572. So this is the decimal form of the given rational number, and it is a terminating decimal again. It is a terminating decimal. It is a terminating decimal. Since the division is completed, we can say that it is a terminating decimal. So that is like this we can find the decimal form, student. This is second bit. Next we have to solve third bit. This is third bit in the first problem. 4 whole 1 by 5. Again we have to find the decimal form and we have to say whether it is terminating or non-terminating repeating. So see, student, it is a mixed fraction. How to convert into improper? 4 5s are 20 plus 1, we can get 21 by 5. 21 by 5. So now have to divide the numerator by the denominator. We get, see here the numerator is 21 and the denominator is 5. It is very clear 21 is greater than 5. So how many times it goes? 4 times. So 5 4s are 20. So 21 minus 20 is 1. So now it want to go write a decimal and 0. How many times it goes? 2 times exactly. 5 2s are 10. So the remainder is 0 and the division is completed here. Therefore we can write 4 whole 1 by 5 is equal to. So what is the decimal form of the given rational number? 4.2. So and we can say therefore it is a terminating decimal. Since the division is completed, it is a terminating decimal. It is a terminating decimal. So very easy, student. It is a terminating decimal. So this is the third bit in the first problem. Next we have to solve fourth. This is fourth bit in the first problem. 2 by 11 is given. Again we have to find the decimal form by dividing the numerator with the denominator. We can get the decimal form. Then after we have to say whether it is terminating or non-terminating repeating. If the division is completed, we can say it is terminating, otherwise it is non-terminating. So now we have to divide the numerator by the denominator. Here the numerator is 2 and the denominator is 11. So here now we have to divide 2 with 11. So it is very clear, student, 2 is less than 11. It won't go and write a decimal and 0. So it goes only one time. 11 ones are 11. 20 minus 11 is 9. And we can write 0. So how many times? 11 8s are 88. 20 minus 88 is 2. So now write one more 0. So it becomes 20. Again 11 ones are 11. 20 minus 11 is 9. Again write 1 0. So again how many times? 11 8s are 88 again. So again we get 2. So every time we are getting 2 here, again it repeats 1 8 1 8, it is repeating 1 8 1 8. Here the division not completed. So we can write therefore 2 by 11 is equal to, the decimal form of the 2 by 11 is equal to 0.1818 and so on. So it can be written as a 0.18 bar. we can write it is as 18 bar. So 18 is repeating, so we can write 18 bar. Therefore, since the division is not completed, it is a non-terminating. Therefore, it is a non-terminating repeating. It is a non-terminating repeating decimal. Non-terminating repeating decimal. So this is the fourth bit, student. Next we have one more, fifth bit. We have to solve fifth bit in the first two problems, student. 8 by 125. So again we have to write the decimal form of the given rational number. By dividing the numerator with the denominator, we can get the decimal form. Then after we have to say whether it has a terminating or non-terminating repeating decimal. So if the division is completed, we can say it is terminating, otherwise it is non-terminating repeating. So 8 by 125 has given. So numerator is 8 and the denominator is 125. It is very clear 8 is less than 125, so it won't go. So write a decimal and a 0. Again it won't go. Again write here 0 and 0. Now it is possible to go. So 125, how many times it goes? It goes 6 times. 125 into 6 is 750. So now 800 minus 750 is 50. Again we can write 10. So how many times it goes? Exactly 4 times. 4 into 125 is 500. So 500 minus 500, remainder is 0. The division is completed here. Therefore we can write 8 by 125 is equal to, so the decimal form of 8 by 125 is 0.064. Therefore it is a terminating decimal. It is a terminating decimal. It is a terminating decimal. Since the division is completed, we can say it is a terminating decimal. So this is the fifth bit in the first problem. Totally there are 5 bits in the first problem. We have completed all the 5 bits, student. In the next class we have to solve second problem. So that's all today's class, student. If you are watching first time, subscribe my channel and share it to your friends. We will meet in the next class with another problem. Hello student, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve a problem from the chapter Real Numbers, exercise 1.3, second problem. So see student, what he is asking to find is, without performing division, state whether the following rational numbers will have a terminating decimal form or a non-terminating repeating decimal form. So student, he has given rational numbers here. So whether the given rational number is a terminating decimal or non-terminating repeating decimal, he is asking, but without performing the division. But in the first problem, so we have found the decimal form of the given rational number by doing the division. But here is saying that without performing the division, we have to say whether whether it will have a terminating decimal or non-terminating repeating decimal, we have to say. So how can we say? See student, before going to solve the problem, so see student, let x is a rational number and x can be written in the form of x is equal to p by q. So here the condition is p comma q are the positive integers and q is not equal to 0. So if q is equal to 0, it becomes p by 0, that is indefinite form. So see here, x is equal to p by q. So in the given rational number, we have to observe the prime factors of q. So see here, if the prime factors of q are in the form of 2 to the power n into 5 to the power m. If the prime factors of q are in the form of 2 to the power n into 5 to the power m. So here n comma m are also positive integers. N comma m are also positive integers including 0. So here including 0 also. N comma m are positive integers including 0. Simply we can say the whole numbers. So q is equal to 2 to the power n into m. So either q is equal to 2 to the power n or 5 to the power m or 2 to the power n into 5 to the power n. Then we can say x will have a terminating decimal form. So otherwise it will have a non-terminating repeating decimal form. So that you have to remember before going to solve the problem. So first x is a rational number, so it is in the form of p by q. So now we have to observe the prime factors of q. If the prime factors of q are in the form of 2 to the power n into 5 to the power m, so here n comma m are positive integers and equal to 0 also. So either it may be 2 to the power n or 5 to the power m or 2 to the power n into 5 to the power m. We can say that the given rational number will have a terminating decimal form, otherwise it will have a non-terminating repeating decimal form. So that you have to remember, student. So now we have to solve the problem. So student, in the second problem totally there are 10 bits. So this is the first bit, 13 divided by 3125. We have to solve one by one. This is the first bit, 13 divided by 3125. So let 13 divided by 3125 is equal to p by q. Let it is p by q. So first we have to observe whether there are any common factors for the given rational number. So here 13, so it will not divide with 13. So now we have to proceed by taking q is equal to, from this we can say q is equal to what? 3125. So now resolving 3125 into its prime factors. So now I am resolving, student, here see here 3125. So since the units digit is 5, it is not divisible by 2. So check whether it is divisible by 3 or not. 3 plus 1 is 4, 4 plus 2 is 6, 6 plus 5 is 11. 11 is also not divisible by 3, hence it is divisible by 5 only. So now I am dividing by 5. 5 6 are 30, 12 is there, 5 2s are 10 and 25, 5 5s are 25. So again it is divisible by 5 only. So 5 1s are 5, again 12 is there, 5 2s are 10, 25 is there, 5 5s are 25. So again it is divisible by 5 only. 5 2s are 10, 5 5s are 25. So again 25 is divisible by 5, it is 25. So how can we write here? 3125 is equal to 5 into 5 into 5 into 5 into 5. Totally how many 5s? 5. 1 2 3 4 5. 1 2 3 4 5. So therefore we can write here q is equal to 3125. How can we write? 5 into 5 into 5 into 5. So how many 5s? 1 2 3 4 5. That is 5 to the power 5. So therefore we can write the q is in the form of 2 to the power n into 5 to the power m. Therefore the given rational number will have a terminating decimal number. Since q is of the form, since q is of the form 2 to the power n into 5 to the power m, the given rational number, will have a terminating decimal form, So like this we have to write, student, since q is of the form 2 to the power n into 5 to the power m, the given rational number will have a terminating decimal form. So the given rational number will have a terminating a decimal form. So this is first bit, student, and next we have to solve second bit. This is second bit in the second problem. 11 by 12 is given. Again we have to say whether it will have a terminating decimal form or non-terminating repeating decimal form by observing the denominator of the given rational number. So see, student, let it is a p by q. Let 11 by 12 is equal to p by q. So first we have to observe whether there are any common factors to the both numerator and denominator. Here it is very clear there are no common factors here. So from this we can say q is equal to 12. So 12 can be written as 2 into 2 into 6. 6 can be written as 2 into 3. So see, student, 12 can be written as 2 into 6, 6 can be written as 2 into 3. Again 2 into 2, 4, 4 into 3, 12. So this is equal to 2 to the power 2 into 3. So here the prime factors of q are not in the form of 2 to the power n into 5 to the power m. So here there is a 3. So we can say the given rational number will have a non-terminating repeating decimal form. So see, student, how can we write since q is not of the form to the power n into 5 to the power m, therefore the given rational number will have a non-terminating repeating decimal form. Repeating decimal form. So like this we can say, student, by observing the prime factors of q. Since the q is not of the form 2 to the power n into 5 to the power m, so therefore the given rational number will have a non-terminating repeating decimal form. So this is the second bit, student. Next we have to solve third bit. This is third bit, student. 64 divided by 455 is given. So again let 64 divided by 455 is equal to p by q. So again we have to observe whether there are any common factors for both the numerator and denominator. So here there are no common factors. So here from this we can get q is equal to 455. So now we have to resolve 455 into its prime factors. So it divides by 5. So 5 9s are 45 and 5 1s are 5. So it is divisible by, so see here 400 and how much it is? 55 only. తప్పు 455. So here it is 91. So we can write 7 1s are 7, 21, 7 3s are 21. So we can write 455 is equal to 5 into 7 into 13. So therefore we can say that Q is equal to 5 into 7 into 13. So since Q is not of the form Q is not of the form, since Q is not of the form 2 to the power n into 5 to the power m, therefore the given rational number will have a non-terminating repeating decimal form. Non-terminating repeating decimal form. So see student, Q is equal to 5 into 7 into 13. Since Q is not of the form 2 to the power n into 5 to the power m, therefore the given rational number will have a non-terminating repeating decimal form. So this is third one student. Next we have to solve fourth bit. This is fourth bit student. 15 divided by 1600 is given. So let 15 divided by 1600 is equal to P by Q. So here there are common factors. So here 5 is the common factor. We have to cancel. 5 3s are 15. Again 5 3s are 15. 1 0 10. 5 2s are 10. Again write a 0. So now it is a 3 by 320. So that we can write 3 by 320 is equal to P by Q. So now Q is of the form Q is equal to, here now there are no common factors for these two. We can write a Q is equal to 320. So now I have to resolve 320 into its prime factors. 320. So it is divisible by 2. 2 1s 2 6 0. Again it is divisible by 2. 2 8s 0. It is divisible by 2. 2 4s 0. It is divisible by 2. 2 20s. Again 2 10s. Again 2 5s. So now how many are there? 1 2 3 4 5 6. 2 to the power 6 into 5 is there. 2 to the power 6 into 5. So therefore we can write 320 is equal to what it is? 1 2 3 4 5 6. 6 2s 2 into 2 into 2 into 2 into 2 into 2. 1 2 3 4 5 6 into 5 is there, 1 5. So how can we write it is 2 to the power 6 into 5. So therefore we can write Q is equal to 2 to the power 6 into 5. Q is equal to what? 320, 2 to the power 6 into 5. So since Q is of the form, so it is Q is in the form of 2 to the power n into 5 to the power m. Therefore, the given rational number will have a terminating decimal form. decimal form. Since q is of the form 2 to the power n into 5 to the power m, therefore the given rational number will have a terminating decimal form. So student, this is a fourth bit, and next we have to solve fifth bit. This is fifth bit in the second problem. 29 divided by 343 is given. So let 29 divided by 343 is equal to p by q. So now I have to observe whether there are any common factors for numerator and the denominator. Here there are no common factors. Now we have to select only denominator, that is 343. So now I have to resolve 343 into its prime factors. It will divide only with 7. So here 7, how many times? 7 4s are 28 is there, 6 63. So 7 9s are 63. Again 7 7s are 49. So we can write 343 is equal to 7 into 7 into 7, that is 7 to the power 3. So therefore we can say q is equal to 7 to the power 3. So here since q is not of the form, since q is not of the form, since q is not of the form, it is not in the form 2 to the power n into 5 to the power m, the given rational number will have, the given rational number will have the given rational number will have a non-terminating repeating decimal form. Therefore the given rational number will have a non-terminating repeating decimal form. Since q is not of the form 2 to the power n into 5 to the power m, q is equal to what? 7 to the power 3. Therefore the given rational number will have a non-terminating repeating decimal form. So student, this is the fifth bit. Next we have to solve. This is sixth bit. 23 divided by 2 to the power 3 into 5 to the power 2. So let q is equal to, let 23 divided by 2 to the power 3 into 5 to the power 2 is equal to p by q. So here there are no common factors for both numerator and the denominator. So we can say q is equal to 2 to the power 3 into 5 to the power 2. So directly it is in the form 2 to the power n into 5 to the power m. So the given rational number will have a terminating decimal. So simple, very easy student. Since q is of the form since q is of the form 2 to the power n into 5 to the power m, therefore the given rational number will have a terminating decimal, form. So see student, since q is of the form 2 to the power n into 5 to the power m, therefore the given rational number will have a terminating decimal form. So this is 6th bit, student. Next we have to solve 7th bit. This is a 7th bit. 129 divided by 2 to the power 2 into 5 to the power 7 into 7 to the power 5. So see, student, how can we find solution? Let 129 divided by 2 to the power 2 into 5 to the power 7 into 7 to the power 5 is equal to p by q. So now we have to observe whether there are any common factors for both the numerator and the denominator. Here there are no common factors, so we can write q is equal to 2 to the power 2 into 5 to the power 7 into 7 to the power 5. Therefore we can say, since q is not of the form, since q is not of the form 2 to the power n into 5 to the power m, the given rational number will have a non-terminating repeating decimal form. Non-terminating repeating decimal form. Non-terminating repeating decimal form. Since q is not of the form 2 to the power n into 5 to the power m, there is 7 to the power 5 here. So the given rational number will have a non-terminating repeating decimal form. So this is a 7th bit, student. Next we have to solve 8th bit. 9 by 15. So let 9 by 15 is equal to p by q. So now we have to observe whether there are any common factors here. So yes, there are common factors. So 3 3s are 9, 3 5s are 15. Therefore here we can get 3 by 5 is equal to p by q. So from this we can write q is equal to 5 only. Therefore we can say, since q is of the form 2 to the power n into 5 to the power m, therefore the given rational number will have a terminating decimal form. So since q is of the form 5 to the power m, that is 5 to the power 1 here, the given rational number will have a terminating decimal form. This is the 8th bit. Next we have to solve. So this is 9th bit, 36 by 100. See here, let q is equal to, 36 by 100 is equal to p by q. 100 is equal to p by q. So here we can cancel by 4. There are common factors. 4 9s are 36, 4 2s are 8 and 20, 4 5s are 20. So here 9 by 25 is equal to p by q. So here q is equal to how much? 25. So it can be written as 5 into 5, that is 5 to the power 2. So q is equal to 5 to the power 2. So therefore, since q is of the form, since q is of the form, q is of the form 2 to the power n into 5 to the power m, the given rational number, the given rational number will have a terminating decimal form, will have a terminating decimal form, will have a terminating decimal form. So very easy, student. So q is in the form of 5 to the power m, actually m is equal to 2 here, therefore the rational number will have a terminating decimal form. This is 9th one, student. Next we have to solve 10th bit, 77 divided by 210. So again let it is a p by q, let 77 divided by 210 is equal to p by q. Again you have to observe if there are common factors, you have to cancel by the common factors. Here 7 11s are 77, 7 3s are 21 and 0. So now it is of the form 11 by 30 is equal to p by q. So now q is equal to 30. So it can be written as 2 into 15. Again 15 can be written as 3 into 5. So q is equal to now 2 into 3 into 5. So since q is not of the form, so we can say since q is not of the form, q is not of the form, since q is not of the form 2 to the power n into 5 to the power m, therefore the given rational number, the given rational number will have, the given rational number will have a terminating, will have a non-terminating repeating decimal form, a repeating decimal form. So this is a 10th bit, student. So it is a non-terminating repeating decimal form. So this is 10th bit, student. There are totally 10 bits in the second problem. All the 10 bits we have completed. So in the next class we have to solve third problem, student. Student, if you are watching first time my channel, subscribe and share to your friends. So that's all today's class. We will meet in the next class with another problem. Hello student, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve a problem from the chapter Real Numbers, exercise 1.3, third problem. So see student, what he is asking to find is write the following rationals in decimal form using theorem 1.4. So student, here he has given some rational numbers. Totally there are 5 bits in the third problem, student. This is first bit, 13 by 25 he has given. He has given a rational number. He is asking to write the given rational number in the decimal form using theorem 1.4. So in the first problem, we have written the decimal form of the given rational numbers by dividing the numerator with the denominator. But here he is asking to write the decimal form of the given rational number using theorem 1.4. So before that, student, you must have clear idea about the theorem 1.4. What is the statement of the theorem 1.4? What it states? How can we find the decimal form of the given rational number using theorem 1.4? So see student, what it says, theorem 1.4, that is if x is a rational number, if x is any rational number, then it is of the form x is equal to p by q. X is a rational number, then it is of the form x is equal to p by q. Then the prime factorization of the q is in the form of 2 to the power n into 5 to the power m. So here n comma m are non-negative integers. Non-negative integers. Non-negative integers. Non-negative integers. So see student, what it says, what is the statement of theorem 1.4? If x is any rational number which is in the form x is equal to p by q, if the prime factorization of q is equal to 2 to the power n into 5 to the power m, here n comma m are non-negative integers, then the decimal form of x is a terminating decimal. Then the decimal form of x is a terminating decimal. Terminating decimal. So this is the theorem 1.4, terminating decimal. So see student, once again, let small x be a rational number which is in the form p by q. If q can be written, if the prime factorization of q is in the form 2 to the power n into 5 to the power m, n comma m are non-negative integers, then x has a terminating decimal. So this is theorem 1.4. How can we write the given rational number in decimal form using this theorem? See student, if the prime factors of q are in the form of 2 to the power n into 5 to the power m, it is nothing but, see here, if we have multiples of 10 in the denominators of the given rational number, it is very easy to write in decimal form. Suppose, see here, all these numbers, suppose I am writing, if you observe, 32 divided by 10, 456 divided by 100, in the same way 1035 divided by 1000. So see student, all the rational numbers, the denominators are multiples of 10. So here it is very easy to write. Here it is 3.2, here it is 4.56, here it is 1.035. So using theorem 1.4, we have to write the denominator, we have to make the denominator in multiples of 10. We have to convert the denominator in multiples of 10. Then it is very easy to write in decimal form. So this is theorem 1.4 student. And now how can we write the given rationals in decimal form using theorem 1.4? So see here. Student, this is first bit in the third problem. 13 by 25 is given. So given rational number is equal to So what is the given rational number? 13 by 25. So now take 13 by 25. So now how to write the prime factors of q? So 13 by 25 can be written as 5 into 5. 5 into 5. So it can be written 13 divided by 5 to the power 2. 5 to the power 2. So to make 5 as 10, so we have to multiply by 2. So for that what I am doing, see here, but here 5 to the power 2 is there, so we have to multiply and divide by 2 to the power 2. 5 to the power 2 is there, so I am multiplying and dividing by 2 to the power 2. So this you have to understand student. So here 13 divided by 40 to the power 2 is there. To make the denominator as multiple of 10. So if it is 5, to make it is as 10, we have to multiply by 2. So if we multiply, we have to divide with 2 also. So here 5 to the power 2 is there. to make the denominator multiple of 10, we have to multiply and divide 2 to the power 2. So if it is 5 to the power 3, you have to multiply by 2 to the power 3. So that's you have to understand here, student. See here, how can we write here? So now I am writing here. So multiply the numerators and the denominator. 13 into 2 to the power 2 can be written as 4, student, divided by 5 square. So here 5 to the power 2 into 2 to the power 2, it can be written as 5 into whole to the power 2. 5 into whole to the power 2. So next here we can write 13 into 4, multiply 13 4s are 52, divided by 5 into 2 is 10, 10 to the power 2. So we can write 52 divided by 10 to the power 2 is 100. 52 divided by 100. So now the denominator is the multiple of 10. Now it is very easy to write the decimal form. So here how can we write? 52 by 10 is equal to 0.52. 0.52. So this is the decimal form of 13 by 25. Therefore we can write 13 divided by 25 is equal to 0.52. So this is the decimal form of the given rational number, student. Just you have to understand this step. We have to make the denominator as the multiples of 10. Then it is very easy to write the decimal form of given rational number using theorem 1.4. So student, this is first bit in the third problem. So next we have to solve this is second bit in the first problem, student. 15 by 16 is given. Again we have to write the decimal form of the given rational number using theorem 1.4. that is, given rational number is equal to 15 by 16 is given. So see here, how can we write 15 divided by 16 equal to. So now we have to make the denominator as the multiple of 10. For that we have to write the prime factors of denominator. 16 can be written as 2 into 8. 8 can be written as 2 into 4, 4 can be written as 2 into 2. So these are the prime factors of 16, student. Again if you multiply 2 2s are 4, 4 2s are 8, 8 2s are 16. So 15 divided by, now it is 2 to the power 4. How many 4s are there? How many 2s are there? 4. 2 to the power 4. So now to make the denominator multiple of 10, if it is only 2, we have to multiply and divide it by 5. So but here 2 to the power 4 is there. Now we have to multiply and divide by 5 to the power 4 to make the denominator as the multiple of 4. So for that what I am doing, see student, 15 divided by 2 to the power 4 into 5 to the power 4 divided by 5 to the power 4. So now see here, 15 into, so 5 to the power 4 is 625, student. 5 into 5 is 25, 25 into 25 is 625. So 15 into 625 divided by, so it can be written as 2 into 5 whole to the power 4. 2 into 5 whole to the power 4. So now I have to multiply 15 into 625. So 15 5s are 75, 5 and 7. 15 2s are 30 plus 7, 37 and 3. 15 6 are 90, 90 plus 3, 93. So now we have 9375 divided by 2 into 5 is 10. So 10 to the power 4. So now 9375 divided by 10 to the power 4 is 10,000, student. How much it is? 10,000. So it is, the decimal form is 0.9375. So see student, how many zeros are there? 1 2 3 4. So now we have to write decimal after 4 digits. 1 2 3 4. So 1 2 3 4, write decimal and write 0 on the left side. So therefore the decimal form of the given rational number 15 by 16 is equal to how much, student? 0.9375. So this is the decimal form of the given rational number. So student, this is second bit, and next we have to solve third bit. This is third bit in the first problem. Again we have to write the decimal form of the given rational number using theorem 1.4. So what he has given is 23 divided by 2 to the power 3 into 5 to the power 2. So given rational number is 23 divided by 2 to the power 3 into 5 to the power 2. So now it is a very easy, student. Already he has given the prime factors of denominator. So 2 to the power 3 into 5 to the power 2. So to write the denominator as the multiple of 10, here we require one more 5. So here 2 to the power 3 is there, 5 to the power 2 is there. So if it is 5 to the power 3, it is very easy. So we have to multiply and divide the given rational number by 5. So now write 2 to the power 3 into 5 to the power 2. So into 5 divided by 5. So just I have multiplied and divided by 5. So now multiply these two. 23 into 15, we can get 115 divided by, it is 2 to the power 3, 5 to the power 2 into 5, again it becomes 5 to the power 3. So now we have 115 divided by, it is 2 into 5 whole to the power 3, 2 into 5 whole to the power 3. So see student, it is 115 divided by, so 2 into 5 is 10 to the power 3, 2 into 5 is 10 to the power 3, very easy now. So it 115 divided by 10 to the power 3 is 10 into 10 into 10, we get 1000. So 115 by 1000 is equal to 0.115. So this is the decimal form of the given rational number. Therefore we can write 23 divided by 2 to the power 3 into 5 to the power 2 is equal to 0.115. So this is a third bit, student. Totally we have 5 bits. Next we have to find the decimal form of student. This is fourth bit in the third problem. 7218 divided by 3 to the power 2 into 5 to the power 2. Again we have to write the decimal form of the given rational number using theorem 1.4. So for that we have to write make the denominator as the multiple of 10. So given rational number, see here how can we write it? 7218 divided by 3 to the power 2 into 5 to the power 2. So write the numerator as usual, 7218 divided by 3 to the power 2 is 3 into 3, that is 9, and write 5 to the power 2 as usual. So here there are common factors for both. 9 ones are 9, here 9 8s are 72. Okay, so 0, 9 2s are 18. So we can get student 802 divided by 5 to the power 2. So now the given rational number converted into 802 divided by 5 to the power 2. So now to make the denominator is 10, we have to multiply and divide by 2 to the power 2. So now I am writing, see here 802 divided by 5 to the power 2 into 2 to the power 2 divided by 2 to the power 2. So see here how can we write it? 802 into 2 to the power 2 is 4 divided by 5 to the power 2 into 2 to the power 2, it can be written as 5 into whole to the power 2, 5 into whole to the power 2. So just we have to multiply these two. So 802 into 4. So see student, so 4 2s are 8 and 4 into 0 is 0, 4 8s are 32, 3208 divided by 5 into 2 is 10, 10 to the power 2. So we can write 3208 divided by 10 to the power 2 is 100. So 10 into 10 is 100. So now the decimal form is 32.08. How much it is? 32.08. So this is the decimal form of the given rational number, student. This is fourth bit. So next we have one more bit in the third problem. Next we have to solve fifth bit. Student, this is fifth bit in the third problem. 143 divided by 110 is given. Again we have to write the decimal form of the rational number using theorem 1.4. So for that we have to make the denominator as the multiple of 10. So see here, given rational number is 143 divided by 110. So again I am writing 143 divided by 110. So student, if there are any common factors for the numerator and denominator, we can cancel with common factor. Here cancel by 11. 11 tens are 110. Again here 11 ones are 11, 33. 11 threes are 33. So now it is 13 by 10. So student, it is very easy. Now it is the denominator is a multiple of 10. It is very easy to write the decimal form. 13 divided by 10 is 1.3. Very easy, student. Therefore we can write 143 divided by 110 is equal to 1.3. So this is the decimal form of the given rational number. So student, this is the fifth bit in the third problem. So all the 5 bits we have completed. So student, if you are watching first time my channel, subscribe and hit the bell icon. Whenever I upload the videos, you can get the notification and share to your friends. So that's all today's class. We will meet in the next class with another problem. Welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve a problem from real number exercise 1.3, fourth problem. See student, what he has given, express the following decimals in the form of p by q and write the prime factors of q. What do you observe? So student, here he has given some decimal numbers. He is asking to write the given decimals in the form of p by q. Then after we have to write the prime factors of q. So there are totally 4 bits in the fourth problem. So this is the first bit, 43.123. How to solve one by one. So before that, student, we must have clear idea about the decimal forms. See here, decimals are of 2 types. Decimals. So we have terminating decimals and non-terminating decimals. So terminating decimals and we have non-terminating decimals. So in the non-terminating, again we have repeating and non-repeating. So non-terminating, repeating and non-terminating, non-repeating. So we have these types of decimals. So student, terminating decimals are rational numbers. These decimals can be converted into p by q form. In the non-terminating decimals, only repeating decimals are rational numbers. These can be converted into p by q form. But non-terminating, non-repeating decimals or irrational numbers, these cannot be converted into p by q form. So now, by observing the given decimals, which type of decimal it is, first we have to identify, then after we have to convert into p by q form. Only terminating and non-terminating repeating decimals can be converted into p by q form. Otherwise, other non-terminating, non-repeating cannot be converted into p by q form. Hence, they are irrational numbers. Only rational numbers can be converted into p by q form. That you have to remember, student. So first we have to solve 43.123 has given first bit. This is the first bit in the fourth problem, 43.123. This is the given decimal. We have to convert into p by q form. Next we have to write the prime factors of q. So see student, how can we write first solution? The given decimal is equal to 43.123. So it is very clear, it is a terminating decimal. It is a terminating decimal. It is a terminating decimal. So it can be converted into p by q form. So terminating decimals are rational numbers. Therefore 43.123 is equal to, so how can we write the p by q form? So first we have to write all the digits of the given decimal. So 43123 divided by, for this decimal write 1. After the decimal we have to observe how many digits are present here. 1, 2, 3. So we have to write 3 zeros in the denominator after 1. So this is the p by q form. Let it is p by q. So from here we can get q is equal to 1000. How much it is? 1000. So this 1000 can be written as 10 into 10 into 10. That is 10 to the power 3. So how many tens are there? 3 tens are. Therefore we can write a q is equal to 10 can be written as 2 into 5 whole to the power 3. So these are the prime factors. The prime factors. Therefore the prime factors of q. The prime factors of q is equal to 2 and 5. So 2 and 5 are the prime factors of q. So this is the first bit, student. So next we have to solve the second bit in the fourth problem, 0.120120 dash dash. Student, you have to notice that there is no dash dash in the textbook, but he has given it is an irrational number. So you must write dash dash, then only it is an irrational number. So see here, the given decimal is equal to 0.120120 dash dash. So see here, if there is dash dash or if there is bar, we can say it is non-terminating. So here it is non-terminating, but whether there are any repeating digits are there in the decimal, you have to observe. So 120 is there, here also 120 is there, but only 1 is there, there is no 20. So here it is not repeating. So here it is a non-terminating, non-repeating decimal. It is a non-terminating, non-repeating decimal. It is a non-terminating, non-repeating decimal. Non-repeating decimal. So non-terminating, non-repeating decimals are irrational numbers. It is a irrational number. So it cannot be converted into p by q form. So simply it is an irrational number. So only rational numbers can be converted into p by q form. So but it is irrational number. That's all. So this is second bit, student. Next in the fourth problem, again we have to write the p by q form of the given decimal. Then after we have to write the prime factors of q. So the given decimal is equal to 43.12 bar. So if there is bar, we can say that it is a non-terminating repeating decimal. Non-terminating repeating decimal. So it is a non-terminating repeating decimal. It is a non-terminating repeating decimal. So non-terminating repeating decimals are also rational numbers. So these can be converted into p by q form. So therefore it is 43.12 bar is equal to. So just see student, you have to remember how I am writing the p by q form of the given decimal. So first we have to write all the digits in the decimal. So 4 3 1 2 minus, we have to subtract the integer part of the decimal. So the digits which are present on the left side of the decimal, we have to subtract. The 4 3 is there on the left side of the decimal. So 4312 minus 43 divided by, now we have to observe the number of digits in the bar. There are 2 digits in the bar, hence we have to write 2 nines in the denominator. So 4312 minus 43, here we can get 4269 divided by 99. So by subtracting we can get 4269. It is divisible by 3. So 4 ones are 4, 12, 4 threes, 3 ones are 3, 12, 3 fours are 12, 3 twos and 3 threes divided by 3 threes and 3 threes. We can get 1423 divided by 33. So this is the p by q form of the given decimal. So now we have to write q is equal to what is there? 33. So 33 can be written as 3 into 11. 3 into 11. Therefore the prime factors of q are, the prime factors of q, the prime factors of q is equal to 3 and 11. 3 and 11. So this is a third bit student, and next we have to solve fourth bit. In the fourth problem, 0.63 bar he has given. Again we have to write the decimal p by q form of the given decimal. Then after we have to write the prime factors of the given decimal number. So the given decimal is equal to 0.63 bar. So it is very clear, it is a non-terminating but repeating. It is a non-terminating repeating decimal. Non-terminating repeating decimal. So non-terminating repeating decimals are rational numbers, therefore it can be converted into p by q form. 0.63 bar is equal to, so how can we convert? First we have to write all the digits, 063. Next we have to subtract the integer part, that is left side digits of the decimal, only 0. Next we have to observe the number of digits in the bar. How many? 2. So we have to write 2 nines. So it can be written as 63 divided by 99. 99. So cancel by directly, it is cancel by 9. 9 11s are 99. 9 7s are 63. We can get 7 by 11. So therefore let it is p by q. So it is p by q. Let it is p by q. So now the q is equal to what? Q equal to 11 here. Therefore the prime factors of q are, the prime factors of q equal to 11. So this is a fourth bit student, and next he is asking what do you observe? So we have observed that so in the first bit 43.123 the prime factors of q are 2 and 5, and in the second bit it is irrational number, so we cannot convert into p by q form. So but in the third bit the prime factors of q are 3 and 11, but in the fourth bit the prime factors of q are only 11. So this is a terminating, it is a irrational number. This is non-terminating, it is also non-terminating. Therefore we have observed that the prime factors of the prime factors of terminating decimals are 2 and 5. Therefore, we have observed that the prime factors of terminating decimals are 2 and 5. So, this is a 4th bit, student. So, we have completed all the 4 bits in the 4th problem. So, next we have to learn one more problem. So, that's all today's class, student. We will meet in the next class with another problem.